Today we're going to talk about angle relationships in triangles. The vocabulary for today is auxiliary line, corollary, interior, exterior, interior angle, exterior angle, and remote interior angle. The triangle sum theorem says that the sum of the angle measure of a triangle is 180 degrees. Measure of angle A plus measure of angle B plus measure of angle C is equal to 180 degrees. An auxiliary line is a line that's added to a figure to aid in a proof. Here we have triangle ABC with auxiliary line L drawn into the picture. We'll be using an auxiliary line to do the triangle sum theorem. Here we have triangle ABC, and we've drawn auxiliary line parallel to BC through A. Here's our triangle angle sum theorem. For triangle ABC is given. We have a triangle and it's labeled ABC. We want to construct an auxiliary line parallel to BC through point A. And the reason that we can do that is because through any 2 points there is one line. Measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 is equal to 180 degrees. Because they make up that linear pair, 1, 2, and 3 equal 180 degrees. They're supplementary. Angle 1 is congruent to angle B because they are alternate interior angles. You can see I extended the line BC so that you could see the two pairs of parallel lines. And 1 is alternate interior to B, and 3 is alternate interior to C. So they're congruent as well. And that's because of alternate interior angles are congruent. Next we have measure of angle 1 equals measure of angle B, and measure of angle 3 is equal to measure of angle C, because the definition of congruence states that one angle's measure is congruent to another angle's measure if they are congruent. Now, doing a substitution, we can show that measure of angle 1 substituted for B gives us measure of angle B plus measure of angle 2, and then substitute C in for 3, plus measure of angle C is equal to 180 degrees. B, angle 2, which is the same as angle A, and angle C are the three angles of the triangle. Therefore, our proof has been proven. Here's an example that we can look at with a car accident. The positions of cars are measured by law enforcement to investigate the collision. We want to use the diagram drawn from the information collected, and we want to find measure of angle X, Y, Z. Our triangle sum theorem says that measure of angle XYZ plus the measure of angle YZX plus the measure of angle ZXY is equal to 180 degrees. Now we need to substitute 40 for YZX and 62 for ZXY. 40 plus 62 is 102. And then we subtract 102 from both sides to give us the measure of angle XYZ as 78. Here, we're going to start with the bottom blue triangle and find the angle of measure MKN first, because that's where we have two angles labeled in one of the triangles. So looking at our triangle, we have 88 plus 48 plus the angle that we don't know, MKN, is equal to 180. Combining 88 and 48 and subtracting it from 180, we get that measure of MKN is equal to 44 degrees. Now we know that going to the second triangle, MKN and JMK, because they have those red angle markers on them, are congruent, so they are both 44 degrees. Plugging those two values in for the second triangle, the red triangle, we find that measure of MJK plus 104 plus 44 is also equal to 180. We simplify. 104 plus 44 is 148, and subtract 148 from both sides, giving us 32 degrees. A corollary is a theorem whose proof follows directly from another theorem. Here are two corollaries for the triangle sum theorem. Here we have the right angles of a right triangle are complementary, so the acute angles are complementary. So D plus E, we know that F is 90, so D plus E plus 90 equals 180. If you subtract 90 from both sides, you get that D plus E is equal to 90. The second one says that the measure of each angle of an equiangular triangle is 60. If we make all of the angles the same letter, X, 3x is equal to 180, which means that each one is equal to 60 degrees. Here's an example. One of the acute angles in a right triangle measures 2x. What is the measure of the other acute angle? We want to let the acute angles be angle A and angle B, with A equal to 2x. The acute angles of a right triangle are complementary, so A plus B must equal 90. Put 2x in for the measure of angle A, and subtract 2x from both sides. Notice that you do not get a numerical answer here, but we get an expression instead. The interior is the set of all points inside a figure. The exterior is the set of all points outside the figure. Looking at our picture here, 1, 2, and 3 are on the interior of the triangle, and 4 is on the exterior of the triangle. An interior angle is formed by two sides of the triangle, so 1, 2, and 3 are interior angles, and an exterior angle is formed by one side of the triangle and an extension of an adjacent side. So angle 4 is an exterior angle. Each exterior angle has two remote interior angles. Remote means far away. So remote interior angles are the two angles that are far away from your exterior angle. So if 4 is our exterior angle, the two angles far away from that are 1 and 2. 3 is adjacent or next to it, so the other two are the ones that are far away or remote. The exterior angle theorem says that the measure of angle 4 is equal to the measure of angle 1 plus the measure of angle 2. This is because 1 plus 2 plus 3 equals 180, and 3 plus 4 also equals 180 because they're a linear pair. So therefore, if you subtract 3 from both of them, then 1 plus 2 has to equal 4. Here's our example. We have measure of angle A plus measure of angle B equals measure of angle BCD. So plugging these in, we get this expression where we have 15 for measure of angle A, measure of angle B is equal to 2x plus 3, and measure of angle BCD is 5x minus 60. When we simplify it, we combine 15 and 3 to get 18. Then we subtract 2x and add 60 to both sides, which gives us 3x equals 78, and divide by 3 to get x equal to 26. However, they did not ask us for x, they asked us for the measure of angle B. So B is equal to 2x plus 3. We plug in 26 for x and get that measure of angle B is 55 degrees. The third angle theorem says that if two angles of one triangle are congruent, the two angles of another triangle, then the third pair of angles are congruent. So if L is congruent to R and M is congruent to S, then N and T must also be congruent. Here's an example of this theorem being used. G and H are congruent, and F and I are congruent. Therefore, K and J must be congruent. So the measure of angle K is equal to the measure of angle J. So we substitute both of the expressions. Subtract 6y squared from both sides to get negative 2y squared equals negative 40. And divide both sides by negative 2 to get y squared by itself. So y squared is equal to 20. Since we're substituting y squared back in, we don't have to square root both sides. So here we make angle K equal to 4y squared, which is what we have from the picture, and instead of y squared we put in 20, so 4 times 20 is 80 degrees for the measure of angle K. And since measure of angle J is equal to K, then measure of angle J is also 80. Here's your lesson quiz. Go ahead and practice some of these questions, see how you do, and tomorrow we'll go over any questions and make sure to do